Hi, everyone. Thank you for joining for the second OE CCOM seminar of this semester. I just want to remind everyone that there are two ways to ask questions. The first way is just entering your question into the Q&A box. That's at the bottom of your screen. If you roll your mouse over the bottom of your Zoom panel, you'll see a black bar pops up and there's a little Q&A. So you can just click that and then you can type your questions into that box. Alternatively, you can ask your own questions, and to do this, also put your mouse over the bottom of your Zoom screen and where you see the participants button, select that, and you're going to see an option to raise your hand. And when you select that raise hand button, me, Alyssa, or Will see it, and then we can unmute you and give you the opportunity to ask your question directly to the speaker. If you forget what your question is or you don't want to ask it anymore, you can alternatively lower your hand. The keyboard command for raising your hand is Alt-Y, and the keyboard command to lower your hand is Option-Y. If you're on a mobile device, there is a menu button in the corner of your Zoom app. Select that and you'll see the raise hand, lower hand button. So I hope that clears up questions about asking questions live. Today's speaker is Hartwell. He is a mechanical engineering fellow from Raytheon Technologies. He's also a UNH alumni and is BS and MS in mechanical engineering, and he has done a diverse work of design for systems that have different requirements and are in a mix of environments, and I'm very proud to also call him my father. And with that, I will turn the presentation over to Hardy, and thank you for being here.
I'm here. Welcome, everyone. Appreciate your having me. Been a long time since I've been at the university, but on and off with Annie. What I'm going to talk to you today about is Raytheon Technologies and the work that we've done in ocean engineering. This was prepared earlier last spring, but then with COVID, things changed. Raytheon has actually gone through a corporate merger with United Technologies in the interim as well. So I had to update the presentation for that. Much of the work here that I'm going to present, you at UNH or people may actually be familiar with it. I'm not directly familiar with some of these activities because they were outside of our local facility, but I'll brief you on those activities. You may, in some cases, know more than I do on that. And then towards the latter half of the project, or the presentation, I'll be talking to you about stuff that we're doing in Portsmouth, which is much more near and dear to me, and you'll probably see the tempo of my enthusiasm. My screen is not clicking. There it is. That's me. You don't need that. Okay, I'll talk a little about who we Raytheon are. We have a presentation that I'll present. Some of our general technologies, our company-wide ocean technology efforts that we've been worked on. Then I'll talk more locally about what we're doing down here in Portsmouth, Rhode Island, in our Sea Power Systems, obviously where we are, our current Sea Power programs, and then the one that I've been working on for the past 6 years, the variable depth sonar system. Bear with us. I mean, we are an engineering company, and this is an opportunity for us to share with academia and students what Raytheon is and what we do. So if it comes off a little bit of a sales pitch, you know, I'm okay with that because we're looking for engineers, we're looking for scientists to support us in our endeavors. And would like to share with you is that while we are a defense company, we do take and leverage those defense technologies to a lot of other applications that, you know, have a broader support, a broader effort. And so let's get started. This is going to be a video, a little bit of propaganda, but it's well presented. and it helps people understand how the breadth of Raytheon Technology companies, what we do from all over the United States and throughout the world. We have facilities here in New England, we have facilities in Texas, California, Florida, Arizona, as well as we're well resided in Europe and most Far East countries.
The most cyber-secure space system in history. A clearer picture of our planet and above it. Doing more with machine vision. A 100% secure internet. Redefining laser performance and portability. Printing innovation on demand. From quantum computing at trillions of operations per second to nanomaterials at 1 billionth of a meter, using crops as living sensors. Applying chemistry to reshape what's possible. Building AI avatars. Forwarding the next wave in communications. Using robotics like no one else. Moving at hypersonic speed with a proven team, solving the most complex challenges across every domain. Raytheon is helping to make the world a safer place.
All right, so that's a little bit in general what Raytheon is. Okay, and many of these videos are actually on YouTube, and you can see at greater depth a lot of the different Raytheon adventures. No, I'm not going down. There it goes. All right. I got to learn to tap twice. Please bear with me. Okay. In general, Raytheon is into ocean technologies. Acoustic sensors is what we do principally in Portsmouth, both active and passive. We apply that to mine countermeasures, ASW, anti-sub warfare, and passive surveillance. Listening, what's happening in the ocean is a significant activity nowadays. The other technologies that we're getting involved with is autonomous surface vehicles and subsurface vessels, essentially robots on the water. It's a big drive by the United States, the Navy, to get they like to use the term warfighter, the soldier, out of the vessels and use the robots in the otherwise dangerous situations. To develop this as well, we use acoustic transducer development, our listening devices, basically our speakers and our microphones for underwater. And then what I've been working on generally have been these launch and recovery systems for the deployment of these systems. We're also involved in program management, which you'll see in some of the other endeavors we've done outside of Portsmouth, information data tech collection, and obviously software. Okay, in the ocean-wide endeavors, Raytheon Company has been collaborating with a number of different universities and research centers, done work with the University of California, San Diego, to design network capabilities for the Ocean Observatory Initiative. I suspect many of you have reached out to that and looked for information and leveraged data from that. We also work with DARPA, which is the Defense Advanced Research Projects Agency. Have an interesting opportunity there. We're actually looking and working with Sea Life to support the detection and surveillance of underwater vehicles and so forth. There are some organic and crustaceans that actually respond to motion in the water. And we're perhaps leveraging that for sensor development. We also supported the geostationary littoral image monitoring radiometer glimmer. Apparently that's with UNH, and I suspect you folks may be more familiar with that than I am, actually. We've also teamed with NOAA for demonstrating surveillance equipment on unmanned aircraft for hurricane surveillance. I'll talk a little bit more of each of them in detail. A little bit of pictures here. This is the Ocean Observatory Initiative. Again, Raytheon worked with developing the blueprint for the digital infrastructure that enables the ocean observatories to collect, process, and transmit data on a 24/7 basis. The contract's about 11 years old now. We started in 2007, and we're still involved with that. The OI Cyber is a research component of the OI system, and also with the Global Observing Systems of Systems, GS. Teammates in this case, we reached out and we worked with MIT, Caltech, JPL, Center for Supercomputing, University of Illinois, HUI, USC, Rutgers, as well as other agencies. It's been a collaborative technology, and Raytheon often gets involved in these kinds of endeavors. What we bring is to this kind of effort is a lot of management skills and process skills that help organize these large projects that wouldn't otherwise be obvious to some of these facilities. But Raytheon, being a corporate company, has that kind of overhead, that rigor, and that maturity to deal with these kinds of programs. And that's typically what we're bringing to the ballgame. The science is done by the scientists, but the overhead, the data management, and the facilitation of sharing that data is what Raytheon can bring to the ballgame. Because those are the kinds of activities we'll do for the Department of Defense. Okay, a little bit more interesting activity is, we call it ears on the ocean floor. The scientists would explore whether living organisms can serve as sensors. All this work is done locally here in Cambridge, Mass, with the division of Raytheon of BBN Technologies. And it's an interesting activity. They found that in this particular case, it was snapping shrimp exhibit unique behavior where they close or create a behavior when they sense a sound. When they create a sound when they sense movement in the water. So they're using that, they're basically a sensor to help us sense where there's other activities. So this is an interesting paper. You can see the bottom there. You can actually look up in more detail about this. But this has been an ongoing effort that Raytheon's done. Okay. This is Glimmer, the activity that's geostational littoral imaging and monitoring. This is in collaboration with the University of New Hampshire. I'm not sure if it's still ongoing, whether we're still under contract, but we had supported this early on. So they use infrared and ultraviolet frequencies to create visual view, physical view, and biological conditions of coastal waters. It helps us determine thermal gradient, salt salinity, and changes. And what we're all looking for is changes. Changes in the environment are near and dear to us right now because of our understanding of climate change and the changes on the environment, how it's affecting our overall quality of life. Finally, a few years ago, we were involved with NOAA to support unmanned aircraft, UAVs, for hurricane detection. And this work here was, Raytheon supported them in the actual providing the devices as well as the collection of the data. Okay, who are we in Portsmouth, Rhode Island? This is missiles. This is the Sea Power Systems. Please bear with me if I get confused, because the Raytheon Missiles and Defense R&D is a new acronym for us. We were Raytheon Systems up until Raytheon. But we're part of the division of the Sea Power Systems. We're located in Portsmouth, Rhode Island. This is our Portsmouth campus, obviously an aerial view. We're right on the Narragansett Bay. The Sea Power Systems, what do we do? Where we provide, we like to use the term warfare solutions, helping the U.S. as well as foreign sales to detect and deter against a broad spectrum of waterborne threats. We develop advanced integrated warfare capabilities, support submarine combat, air, anti-submarine warfare, and organic countermeasures missions. We love acronyms. You'll see we use acronyms a lot. Anti-mine warfare and anti-sub warfare are the two that we do a lot with here. What you're going to see in some of these presentations, in the presentations and the movies, is how we have different sensors and what we call threat neutralization devices, for lack of a better term, where we combine systems to create a detection and neutralization capability and identification capability. So we do that with our acoustic sensors, we do that with our communications, and then we do that with our, in this case, it would be torpedoes, for lack of a better word. Where again are we in Raytheon Portsmouth? Just briefly, you can see Portsmouth. That's obviously a map of a chart of Narragansett Bay. We're kind of in the center of a lot of other ancillary or peripheral ocean technologies. The University of Rhode Island, Graduate School of Oceanography is across the bay. Naval Under Warfare Center of the Navy is in Middletown, Rhode Island. General Dynamics is across the way, and you can see how we're located between Providence and Newport, Rhode Island. This is just for the perspective. Again, a little bit of selling here. It's a great place, not unlike Great Bay and Portsmouth, but Rhode Island is a great city to live in the ocean industries. Okay, again, as I said before, our current programs are mine countermeasures. Specifically, we have the AN-AQS-20, which is a towed mine detection sensor. This is an interesting device, which we'll show some more films of. And this has been an ongoing program for about 20 years. We have the Barracuda system, which is a mine counter neutralization and identification system, as well as the airborne mine neutralization system, which is launched from a helicopter. The Barracuda system you see is very much state-of-the-art. It's basically a small little drone that gets launched and detects, identifies a threat, a mine threat, and then is instructed to neutralize it. The program that I've been working on is the anti-sub warfare, particularly the AN-SQS-62 variable depth sonar, which I'll talk a little bit more about. One of the things you'll find is that for the acoustic engineers or potential acoustic engineers, the types of sonars that we built are a broad spectrum. If you're looking for a mine, you're looking at small objects. So your arrays, your sensor array is typically small, and it has very high frequencies because your wavelength is typically a function of the physical size of the device or the threat you're trying to detect. In the case of the ASW mission and submarine detection, you use low frequency, long wavelength for large vessel detection, okay? And they're typically higher power, they travel further in the water, with less attenuation. In the case of the mines, you're up close and near to them, so you typically don't have as much power, but you're a much higher frequency, so your attenuations are different too. So those are some of the differences between the types of sonars and acoustic sensors that Raytheon builds. Okay, the Mine Hunter, the HUS-20 Mine Hunter, actually has 4 sonars mounted in the belly, in the sides, and a forward-looking sonar. Okay, this particular sonar, we'll call it a towfish for lack of a better word, is about 12, 14 feet long. It's actually, it flies itself under the water. It's a towed vehicle. Initially it was towed by a helicopter at about 40 knots, and it updated and corrected and flew itself in the water at that speed. Since that time, they've actually come off the helicopter because the Navy discontinued that helicopter. Now we're being launched from either a ship vessel, or the new endeavor is to launch these from unmanned USVs, unmanned surface vessels. And the Navy has a whole raft of US surface vessels that they're developing over the next 10 years. And what you see here is a launch and recovery device that was developed here in the upper left-hand corner that Raytheon is prototyping right now off of Pensacola, Florida, to launch this device. Okay, this is Barracuda. This is a very new program. This is a fully autonomous device that it's called an expendable mine neutralizing off of a UAV. What happens is this UAV will go out and traverse, and it will, and the movie will explain this, it will scan a field where they believe there are mines, and it'll go on a search pattern, and it'll launch these Barracuda robots, and they'll go off and detect missiles. They'll not missiles. They'll like to detect mines. They'll identify them, transfer their information back to the parent ship, confirm the detection of what it is they see, take instruction from the ship to then neutralize and basically blow up the mine. And let's show a video here that'll explain some of that. You're going to go to the next page and go. So here's the suspected minefield. This is the UAV launching the sonar. This is a towed vessel now. So you can see the UAV the sonar is below the surface. The UAV is on the top. The sonar will detect a mine. It'll send a position. If it detects something, makes a contact, send that up to the UAV. It will launch the Barracuda, the bi-neutralizer. That will then relay that I've been launched back to the primary ship. In this case, it's a littoral combat ship. It'll acknowledge receipt. It'll deploy the robot. The robot will go off and then do the fine-tuning and detection of the threat. It'll find the submersible threat. In this case, it's a bottom mine. Echoes back. I found something. Waits for a command. And then acknowledges it, and then a small charge, and it'll neutralize the mine. And that's for an ocean floor mine. It also does it for floating mines. These are the more common ones. These are often a threat in the Gulf Wars. essentially, some of this, the robotic technology and the acoustic sensors don't have to be obviously used for threat detection or threat neutralization, but can be used for other kinds of research endeavors or inquiries. So all of that technology was developed here at Raytheon, and again, what I've shown there is we're putting a system together. Bear with me. There we go. No, page down. Okay. An airborne neutralization system. This is an ability to basically launch a torpedo from a helicopter. Okay. This is probably the end section of the next group that I'm going to show you, where we identify, well, we search, we identify, and then we neutralize. And this system here is actually, there are 4 units that are actually part of a pod that get launched from under the wing of a helicopter. There's also the ALS, which is an airborne low frequency sonar. This complements the AMNS system in the search for threats. Okay, this does the localized searching to help detect locally where a threat is. Whereas the next system that we're going to talk about here, which is what I've been working on, is the ASW system that does large area searches as a towed array from the back of a ship for searching for submarines. What's unique about this system is typically in Navy systems, the sonars, most systems have what they call bow sonars, and the bow it's on the bow of the ship in the very forward end, and it's a bulb that's on the bow of the ship, and that's where the transmitter is. They typically have a towed array, and the towed array typically floats along the surface. Unfortunately, and many of you are probably aware of this, there are thermoclines in the ocean, and acoustic waves will bounce off those thermoclines. Well, that's actually where many submarines, and the U.S. included, hide below the thermoclines. The thermoclines are nominally anywhere from 300 to 600 feet deep, depending on where you are in the ocean, and other factors of salinity and temperature and so forth. But anyway, the state-of-the-art systems are what we call a variable depth system, which actually gets the sonar or the receive array, which is what we call the MFTA on the back end here, and the transmitter, which is the towed body in the middle here, below the thermocline. Currently, as I said, you have a bow array, you have a bow sonar on the front of the ship. It's transmitting, and you have a towed array in the back of the ship that's trying to listen. Unfortunately, you're above the thermocline. You also have the propellers from the ships in between your source and your receive. Well, you can filter that out because you know what the frequencies are, but it still attenuates your signal and the quality of the response. If you can get your transmitter and your receiver below the thermocline, behind the ship, the factor of the improvement in performance is a factor of 10. It's a game changer. And this is the technology we're working on right now. Okay, so the challenge here is we have to launch and recover this system, and it's not trivial. The winch that we've designed, we have 1,500 feet of cable that the towed body is towed with. There's an extension cable that the MFTA is towed off the back of the towed body, which is 3,000 feet, and the receiver array itself is about 700 feet. We have almost a mile of cable that we're towing behind this ship with 2 sensors on it, a transmitter and a receiver array, that have to be coiled up. And that launch and recovery system was a significant engineering effort that was developed at Raytheon in Portsmouth. This system, we worked in conjunction with the folks at Harbor Branch Oceanographic Institute, which is now part of the Florida Atlantic University. For those of you who might be familiar with it, HBOI is in Fort Pierce, Florida. In its heyday, it was very much comparable to the activities at Roots Hole or Scripps Institute or the University of Oregon or University of Rhode Island or UNH. Harbor Branch was its own private organization. It was part of the Johnson & Johnson family, and they actually had built a number of manned submersibles that went down to about 3,000 feet. They weren't quite as ambitious as the Alvin, but they were very unique submarines that were built at Harbor Branch Oceanographic Institute. And Raytheon has had a long relationship with them where they help us develop systems, and we look to them as actually being a skunk works. We do the engineering and the project management and the ideas, and they bring the actual manufacturing and the nuts and bolts to them. What you see here is a launch and recovery system on the left-hand side, and then a demonstration of our towed array that was designed by Raytheon and built down at Harbor Branch, where we did simulated launchings off their dock pier, which is actually very interesting, unique pier in that it's actually connected to the Intercoastal Waterway in Fort Pierce. This here is a video of the testing that we did at Harbor Branch Oceanographic Institute back in 2000. And this was on about a 60, 70 foot support vessel where we mounted our launch and recovery system that was built at Harbor Branch on their ship. And what we had to do is we had to actually simulate the drag from our MFTA using drag chutes. And then to ensure we got the depth, we used a small piece of chain here to submerge the drogues in order to allow the towed system to operate at close to at a reasonable depth for our operation. Here, the benefit here, this is probably 6 years ago when GoPros were actually quite popular. In our case, we leveraged GoPros and we used them on actually the submersible video that you saw here. What we're doing here is transferring the load from a capstan from the towed array to the back of the towed body. Now this demonstration here doesn't have the receive array. It just has the towed body itself. This is primarily mechanical testing. We're doing prove out the stability and the capability of the launch and recovery system. It's a fully hydraulic system. At this stage, it's just a manual system, but it is since updated to be semi-autonomous, and we actually operate it from a laptop. And in this early stage here, it's being operated more on the backhoe. The interesting thing is here, some of the technologies are not much different than what's already on research vessels. The System. That was 6 years ago now, and that was the team on the Intercoastal Waterway coming back. But if you guys ever, if you need a collaborative effort with a facility, the Harbor Branch Oceanographic Institute is a very capable system, very capable group of people, and they have a lot of fabrication capabilities. All right, the final video I have here, which I think we're doing pretty good, it's about 10, 12 minutes to go, is about a 3-minute video. It's going to show you how all the technologies come together. It's an animation, candidly, but this was probably this is probably 3 years old. What you're seeing now is actually happening on board a Navy vessel, okay? And you're going to see the sense of the threat, the identification of the threat, and then what Raytheon likes to say in our, I'll call it our PC vernacular, threat neutralization. Basically, we shoot the bad guys. System being loaded, being offboarded from the back of the ship. There it is in the water. In this case here, the transmitter rotates up, and that's the transmitting array. And that's sending out the signal. You see in the dark, it detects a threat. It's identified the threat. It sends it back up from the receiving array up to the ship. Ship then can identify that it is in fact a threat. The ship then launches helicopters, and the helicopters, there are 2 helicopters. One has the mouse system, which helps now more explicitly locate and define with precision where the threat is. This would be a higher frequency sonar, less power than the sonar on the tow body. It sends a signal back to the helicopter, and then it launches its torpedo. The torpedo homes in on the threat, and the threat is neutralized. A little morbid, but unfortunately, you know, deterrence is a capability, and that carrier by 4,000 sailors on it. And the purpose of these are to protect those sailors. And that's about it. I'm open to questions now.
Great, thank you. Yeah, so feel free to enter your questions into the chat, or you can also raise your hand, virtual hand.
I'll keep my screen on so I can go back to pictures if necessary. Does that work?
Sure.
If I spoke too fast, there's a lot of information. If I left things out, it's, again, trying to cram a lot in a little bit of time.
We have a couple questions here. So one is from Sally. She asks, has Raytheon ever worked with the National Geospatial Intelligence Agency?
Again, National who?
Geospatial Intelligence Agency.
I don't know offhand. If particularly interested, I could, you know, we could exchange information that you could send me through Anne Marie, and I can probably search that out. Again, because we've just recently combined with United Technologies, Raytheon had 80,000 employees. Now we're almost 200,000 employees. We're in many more places. We very well could have, through United Technologies, supported them, but I can find that out for you.
Alyssa, Martin has a question.
Okay, go ahead.
Oh yeah, hi. Very nice presentation, overview of many different projects. I was wondering what the typical composition of your engineering or scientist team is that takes on one of these tasks.
They can be very large. I mean, the program that we started with, this what we call the DART program, the ANSQS 62, started off as actually a very small team. There were probably only 4 or 5 of us. There were 2 or 3 principal engineers. There was a principal, we'll call him business development person, who was working with the Navy. Because really, the part of the challenge is the Navy doesn't always know what they want. So we have people that go out and try to find what the Navy needs, and we have technologies that can help them. And they bring it back to us. And with this small group we had, like I said, 3 or 4 engineers, we have 2 or 3 designers, and we brought that system to the capability you saw on the red ship where we did the testing in Florida. Since that time, this program has blossomed into a team of probably a dozen major engineers, electrical engineering, systems engineering, and mechanical engineering, as well as support engineering, we call whole life support. And the manufacturing effort for both internal, which we're going to do with the sonars, is probably 50, 60 people. So these programs have blossomed. You know, this is a $200 or $300 million program over a period of about 20, 15 years. And the goal for us will be to deliver 16 systems to the Navy over the next 20 years.
Okay. Do you have any? Could you comment on the background of the other members of the team? Are there other scientists involved? Ocean engineers?
We rely. One of the big people that really help the sonars are acoustic. If I get the term right, acousticians, right, which are mechanical engineers typically, or electrical engineers, that are really in tune with acoustics, sound development, and sensing. Typically, they're advanced degrees. Okay, they have special training, and the challenge is right now. One of our senior acoustic engineers actually recently retired. Now we have 2 or 3 other people that we've been mentoring and bringing them along, but you know, candidly, the graybeards are moving on. And it's an open field. It's an open opportunity at Raytheon and other facilities, both within Newark, Naval Underwater Research Center, as well as other defense contractors. We need more acoustic engineers, people that are familiar with underwater sensing, underwater analyzing the data, and knowing how to filter the data to determine what it is you're seeing, and how to filter the data so you get extraneous signals out. And so we have that need. We also have a significant need for mathematicians as well as analysts, both structural and thermal analysts.
Okay, well, thank you. I'm sure the acoustics graduate students in the room just perked up.
Good. I mean, like I say, Raytheon, despite what you may have read in the Boston Globe this morning, that was the United Technologies commercial aerospace side. Raytheon in the defense industry is actually hiring people right now. We have a mandate to hire several thousand engineers over the next 2 years.
Great. We have another question from Val. He asked, what is the speed that can be achieved with a tow body deployed to depths that would be required to get below the thermocline, say 150 to 200 feet?
Okay, we actually have an operating speed of launching between 8 and 10 knots. We have an operating transmitting speed between 8 and 23 knots. The particular vessels that we're being towed by are unique vessels. The Littoral Combat Ship is a very fast ship, and we have to show capability performance up to that. Right now, we're showing performance at requirements to about 14 knots. Some of the challenges we have is in getting the stability of our towed body. And so there's a lot of hydrodynamic efforts. We work with Carter Rock Underwater or Surface Warfare Center down in Maryland, and we've actually done testing of our towed body and their tow tanks. And that's one of the endeavors we have right now, is to understand hydrodynamic stability. We have a very unique roll problem right now up at higher frequencies and up at higher speeds. But ultimately, we'll be operating at about 23 knots.
And there's a second part to this question. So the second part is, if a ship has a system deployed and the enemy submarine launches a torpedo at it, can it jettison the deployed system quickly to maneuver?
We have two ways to do it. One, the array will close up, and we're capable of we're capable of operating with a towed body, but not transmitting. But you saw the way the transmitter kind of has like a jackknife. It opens and closes. In the closed position, we can be towed at north of 35 knots. Okay, the ship is actually more capable of that, and they actually have a guillotine on the towed array, which they would cut, and they'll sacrifice the towed array and the towed body to save the ship.
John Ross has a question.
Okay, yes. Do you want to unmute him?
Hello?
Can you hear me?
Yep.
I hear you.
Yeah, so my question was just that I know a little bit about the LCS program, and I know that the Navy was trying to make it sort of very modular to put lots of different mission packages on it. I'm assuming this is one of them, and would you see it, become more popular, I guess, across other types of Navy ships in the future, or could this system be put on other ships, do you think?
I'm glad you're listening. Yes, we have this. The paradigm 4 or 5 years ago when this program was initiated was we used the term mission modules. We had to fit in a 8x8 by 20 ISO shelter configuration. This system is comprised with 4 mission modules that are transportable by ISO container. Okay, that shape factor drove the architecture of the system. Okay, such that we had to build our building blocks to fit in that 8x8 by 20 containment. One of the challenges they didn't appreciate, though, is the tow loads and the tow forces for a towed array at the speeds they want to go to were far more dramatic and higher than they anticipated. The ship itself has had to be modified significantly to support this towed configuration, the winches, and the launch and recovery system at the speeds they want to operate. So while we have a modular configuration, they will probably not maintain that paradigm for the ships going forward. However, in that vein, though, because we built it that way, we're able to leverage that, and we're being looked at for what they call the smaller, medium unmanned surface vessels for autonomous ASW capability in a ISO container configuration. And we're actually, I just got done looking at a concept where we took the four mission modules and we condensed it down to 2. Now, to do that, I had to make some concessions. One of the things I explained to you is I've got almost a mile of cable that I'm drawing on. Well, the reason the cable's so long is because I go so fast, and I need a lot of cable to get the towed body below the thermocline. If I go slower, the towed body sinks lower. I don't need as much cable. I can make my winch smaller. I can fit on smaller ships. So there's a lot of opportunity here to leverage what we started with and expand into other vessels and other venues.
We have, looks like 2 more questions. The first is, can you talk a little bit about general aerial technologies Raytheon is working on, like different aircraft? Airborne
defenses and so forth in the West Coast. we have a lot of airborne radars that we build, nose radars that were actually built in conjunction with Hughes Aircraft, which was now one of their divisions is a division of Raytheon. And we do nose radars for fighter jets. We've done in the case of United Technologies, obviously we have the Pratt & Whitney division, which does commercial and military jet engines. There's also Collins Rockwell in St. Louis in the Midwest, which does avionics and aircraft systems, HVAC systems and so forth for aircraft. The folks in New England, we're principally ground-based missile defense and sea-based systems, sea-based sensors and stuff, which is what I'm involved with down in Portsmouth. But in the Massachusetts area, you might drive by that Andover plant. They build a lot of the radars for airborne defense. And it's legacy from the days of what we call the Star Wars Initiative. But that's one of Raytheon's, and if you're probably quite familiar with the Patriot system, that's an airborne defense system or a ground-based defense system for airborne threats, both missiles and aircraft. Does that help?
I think so. So we'll take our last question here. Are the towed body systems designed more for only open ocean, or also can they be for estuaries and coastal areas that are more developed?
Why there's any reason we couldn't? You know, you're probably limited by the vessel you're being towed on. As we go and develop with what we call the USVs, both the medium and the lightweight, which will be vessels anywhere from probably 10 meters to 100 meters. They're much shallower draft vessels. There's no reason we couldn't go in shallower water. One of the challenges with our system is it's currently configured because we want to operate at very high speeds and we want to be at the depth. That towed body weighs 4,000 pounds. About 1,500 pounds of that is lead in the nose to keep the nose and the pitch of the body oriented. Because if you notice, we're what we call a mid-body tow. We're not a nose tow. Normally, a lot of towed fish will actually be pulling from the nose. Because we have the array we have to deploy, we do a mid-body tow. So the challenge is we have to ballast the body in the nose so we keep the nose down and we remain horizontal. One of the challenges is we have to keep the array vertical in the water so that our transmitted signal is omnidirectional, radially around, circumferentially around the ship. I mean, around the transmitter. So, but if you made that towed body lighter, you could go in shallower waters and at slower speeds.
Great. Well, thank you for answering all these questions and for speaking with us. Thanks for everyone who attended, and I hope everyone has a great weekend.
Thank you for having me. I appreciate it.